Welcome, my name is Sharon. With my partner Zixiao, we are graduate students in electrical engineering at Columbia University. This is our project image translator for the course Big Data Analytics. Hope you like it. The main function of our product image translator is to translate black and white images into the colorful images. Before we stepped into the digital colorful world, the photos we took and the movies we watched were all in black and white. This only allowed us to take the contour of history while eliminating color. When we wanted to restore some historical scenes, the first thing came up was to restore color. With big enough datasets of black and white and corresponding colorful images, we implemented an algorithm of Conditional Generative Adversarial Nets and built our model. The main tools we are using is TensorFlow. It is where we build our model. And on the Google Cloud Platform, we train our model. The main programming language we're using is Python. And we also implemented Flask, HTML, CSS, JavaScript for the web application. The main dataset we're using is mainly from the ImageNet, where we contain 20,000 pictures of various categories. As for the main algorithm we're using is Conditional GAN. Here we can see there is a generator and there's a discriminator. The process is like, first we put the grayscale image into the generator, and then the generator will generate a fake colorful image, and then concatenate with the grayscale image, and put them together in the discriminator. On the other side of the discriminator, the original image concatenate with the grayscale image, and put them together in the discriminator. Thus, the discriminator will tell which one is real and which one is fake, and then give feedback to the generator. After times of training, the generator will then promote its performance to generate a more lifelike image. During the data preprocessing, firstly we resize our picture and then transform it into the grayscale image, and take them as a pair and put them together in the TF records files, which is more convenient and more easy for us to train our model.
Our generator has the structure of a U-net, which means first we have several convolution layers and then several deconvolution layers. We will concatenate the convolution results to its corresponding deconvolution layers to form skip connection. This is very important for colorization because it can help us keep more information from the original images. And here are some details about our model. First, as for generator, it has total 12 layers, and each layer has convolution, batch normalization, and value activation functions. The first 6 layers form an encoder, and the last 6 layers form a decoder. And as for our discriminator, it shares the same structure as the encoder parts of our generator. After we gathered our data and built a model, we began to train it. Here are the losses of both our discriminator and the generator. As you can see, we can observe the adversary actions in these graphs. Whenever the loss of the discriminator is decreasing, the loss of the generator will increase, which means they are fighting against each other. And in the long run, we can see the loss of our generator is decreasing, which means it really learned something from the training data, which can help it deceive the discriminator. Here are some results we sampled during our training process. As you can see, at first, the generator can only generate some noises, and after several epochs, it can generate some colorful images, but not that vivid. And after 8 hours training our model, it can finally generate some results which are really lifelike.
While our project is different from others, firstly, our model can deal with variable size images. For some other applications, there is always limitation on the image size. But with our product, you can actually translate any image as you want. And secondly, the structure of a model has strong adaptability. It can achieve different effects in terms of different training dataset. You can change the edge of a cat into a real cat, or the cartoon into a real-life person, just by changing the training dataset. In the future, we're going to apply this technology into the black and white videos or the black and white movies. And secondly, we're going to improve our website towards perfection. Here comes our demonstration part. Let's choose a picture. Firstly, choose a submit. It's still loading. Here it goes. And we can change another. Charlie Chaplin. Submit. Just be a little bit patient. Here it goes. And change the landscape. Here's the landscape. Okay. Sun. Wait for the beautiful landscape. Okay, here it goes. Thank you. That's our demonstration and our project.